Okay, so I wanted to do a really quick video. I did a upgrade. Now I do light editing for video. I do more photography, graphic design and things like that. But I'm not as strange to building high performance, world beating monster systems with all flashing lights, etc. There's some systems floating around on this video to use to peruse, and as you'll see, this is the kind of thing we get up to. Now, I've been out of touch with a lot of IT stuff, and it's what's actually happened. Now, in the last 3 years, so going back to 2017, a lot's happened. And recently there's been the Gen this, Gen that, Gen's these, and Gen's other one, and it got really confusing. In fact, I went for a 1660 graphics card thinking it was actually going to be better than the 1050, and boy was I wrong. So, you know, there's a very much real confusion as to what actually is what. I mean, it's like this rate. Ryzen 7, yeah, Gen 3, right? So you think that 5, 7 and 9, yeah? Well, I thought, well, maybe these are Gen 2, but it turns out it's the clocks, the cores on it, and then it's a 2700X, so that's a decent one. What about the 37? Oh no, actually the 3 is Gen 3. So yeah, you get huge amounts of problems with what they claim is what. And so you're just sat there going, oh really, what is best? Now, a 1660 I would took from the 660 cards from back in the day, and I thought, well, you know, that I had 2 of those, the 1660 GTs, and thrashed the 8800 Ultras, and of course that was, I think I paid less for 2 cards than one of the high performance cards, and plus it was SLI and load balanced and memory share and everything else, so it was a decent system, and in fact that's the one I thrashed Alienware with. So, you know, when you're picking your hardware, it's not going to be easy. It is confusing as to what's what and what outranks what, and there I'm going to put a slide up of somewhere which shows something about the different graphics cards and where they kind of stack with performance, because there's you've got all these people going through with their marketed and promoted review sites which give you really stupid information, and then you get some foreign guy who's doing side-by-sides and you can kind of like see what's actually going on. So it's important that you really do a lot of research, and if you want to spend, I spent 6 months doing research just to get myself back up to speed of what was what performed. Now the 1660 should have performed a lot better, about 30% better than what it's actually performing, but I found out it's probably going to be a driver's firmware or BIOS issue in there, and I contacted the manufacturers to find out, and they said, oh, just send it back to us because it's crap. So, you know, there was that consideration as well. I mean, I was looking at the performance records of what they did, and NVIDIA claimed that it was 100% faster. So I did a load of benchmarks, and the benchmarks actually turned out to be only about 25 to 45% faster. So obviously they're lying again. They're marketing again. So, you know, this is the problem you get with these types of companies, that they offer you incentives to buy their latest and greatest because of their financial problems, and then you go out and buy it, and then you're disappointed because what you've just bought was a complete flipping waste of money. Now, I'm not saying it's a complete waste of money. It's got 30 frames or 40 frames on average above on a benchmark run side by side on exactly the same hardware, you know, and the system upgrades and blah blah blah, so we could actually see what was actually going on. But yeah, so the problem with video editors is that you're not going to go down mainstream unless you're going down towards the mid to lower end cards. Ideally you want to be going for the Quadro cards. They're your choice cards. So if you want to be doing serious video editing, get a Quadro. You have more CUDA cores, which is what are used for rendering, and thus if you go through, they'll always say what CUDA cores they are. So like, you know, a good end is probably the P4000, 5000 and 6000, although their prices probably are about exactly the same as the model numbers. So when you go through and if you find that your software is GPU software, then literally you need to go for something like the X570 boards. They have the PCI Express lanes to run the GPU one. But I use a lot of CPU, so multi-core was more important for me. Now there's some videos and they're marketing staged videos and they go, oh well, I needed an Intel processor with blah 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 blah, and it was brilliant and the sun shined out of his arse. And you know, they're 12-year-olds, you know, and they passed their GCSEs when they were so downgraded that, you know, if you got an A back in any time past 1996 or something like that, that it was the equivalent to a D back in the day when I was at school. So yeah, so I built my one without really a budget in mind. It was about getting the right type of a performance for the lowest price that did the job. So I didn't really set a budget. I knew I had, like, you know, money to spend, but it's how much money do you really want to spend on it and where could the rest of your money go. So one of the things I did is I built the computer system as an upgrade to my older system, and then I decided with all the money I saved to buy myself a high-spec monitor. Although high-spec monitor is really debatable, because when I first got it I thought, oh my god, I've really bought a lot of rubbish, it needs to go back. Yeah. So another guy who did video editing recommended it. He said, oh yeah, you can do video editing on this, blah 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 blah. And then I touched it and I'm like, no, 2 screens is so much better. So yeah, don't go with 1 screen, bigger screen. It still doesn't work from when, you know, when you go from, like, click on your 1 screen, maximize out your software on there so you can see it better. Yeah, you can't do that on another single monitor. So there is plenty of drawbacks, although, you know, it's a nice monitor, don't get me wrong. Apart from I had to manually set the whole thing up just so it actually worked properly. That's probably a downside, but it is a Philips one, so it explains quite a lot, because normally I wouldn't go near a Philips monitor because, well, yeah, they're Philips monitors. So yeah, so the obviously you're going to be looking at, you know, I need to get a new mouse. I've had my mouse now, it's a wireless mouse, I've had it since the Stone Age. I've just literally got rid of the keyboard because it had a fault, some sort of fault on it. So yeah, so I've gone over and I've just chucked in a Dell one there at the moment. So, you know, for me it's about, you know, what you look at and what you're touching is the important thing, because that's what you see all the time. I mean, my case wasn't important to me from a perspective of, oh, does it look really pretty or not? Because my case isn't on show, it's just literally thrown under my desk. In fact, I've got a glass side case and the glass is against the wall in there because I have server racks and arrays on my other side of my desk. So, of course, you know, you don't really see it. So, it just needed to be cool enough. So, and I don't mean cool as in like street cool, I mean cool as in air cold. Coldness of it. So, you know, if you're going to upgrade from sort of like the i5s and i7s, then yeah, the AMD is much better. I'm just trying to think really. You probably got, if you've got a 1050 Ti, don't bother upgrading. Just keep with what you've got. It's not, there isn't that much difference between the on, you know, on gaming cards or run-of-the-mill cards. There isn't that much difference in any of them. If the 2080 is supposed to be, you know, 45% better or 55% better than the card that I've got in there, then it's still flipping abysmal. So, you know, just think of it that way. So yeah, go for the Quadros. AMD is perfectly fine. When you go for Quadros, get the Titan type. You know, they're called the Titans, non-graphical ones. They're just literally GPU compute, because that's all your software will want to use. So yeah, but you can go down lower grade on your processor, but you need to be careful because of your motherboard and whether the PCI Express lanes are there. Once you go down in certain ones, I know that 4 times is perfectly fine for video editing. However, if you had 8 or 16 times, you probably will like it. And as software develops and the hardware develops and certain things drop down in price, you may want to upgrade by slapping in a couple of extra graphic cards and running at full speed. So your latest chipset is essential when buying a motherboard. What you pay in your motherboard, and there's a lot of information about this on motherboards about poor quality VRMs. Now MSI got a good review and then bad reviews. Gigabyte's kind of like been in the middle, and Gigabyte really do scrutinise and test their results. I've seen the factory videos when they actually make them and test them, and they shove them in these great big huge massive machines to test all the motherboards. And to be honest, I've had Gigabyte motherboards and I've never had any issues with them at all. I've had Asus motherboards which usually start with a considerable amount of issues and they melt. I've had MSI boards which I find are kind of like, you know, they're kind of like a budget board. They're a bit flexible, they do the job. They're a Renault essentially, you know, they're pretty good and then they break. But they don't break that often. They're fit for what their purpose they do and they're left alone, so that's perfectly fine. I don't disrespect MSI, I think they make pretty good boards. Asus are just literally, they want to be the first person to have it out, and they literally just get stuff, throw it in a box and then just go, yay, there we go, we done it. Yeah, we're the first ones, buy this one, £7,000 above you know, everybody else. So that's the problem you get with Asus. Gigabyte are kind of like, yeah, well, we'll get a board eventually, we just got to pass it through a load of tests. Hang on, we stamp on it a couple of times, yeah, it still survived and still works, yes, you can have it. So, you know, that's the kind of way that I look at the different companies. Now, AMD, they're kind of like a weird company, aren't they, really? There's a lot of technical whiffery about the what's best, CDPs and information and marketing as usual. I mean, they're pretty good. The software, everything they do nowadays seems to relate down to drivers, BIOS and firmware. Now these three things are really important because that's how everything works. I mean, if you work from a server environment, you know that, you know, everything's kind of like departmentalized and pulled together with the BIOS, and it has its own firmware and startup things and everything else, so that's fine. But when it comes to the motherboards in domestic systems, they're all kind of like, you know, the hardware's all forced together and it runs off a single BIOS and not so much firmware integrating in and having to communicate, so that kind of works completely differently. But the problem that I find is that, you know, it's just down to you can't manually get into the system and manually set the systems as easy as you should be able to, or easy as you could. Now the 1660 graphic card is a perfect example. I can whack that up to over 2000 on the core and 5000 on the memory, which brings it up to their top of the range cards, you know. And so what I found is that it does do it. It will hold it and fine, and it'll run there for, you know, a split second, and then it just throttles itself back. Not because it's overheating or there's any other issue with it, it just does it. So you can't get the max performance out of it. In fact, even on the stock settings, I found it kept on dropping back. So obviously when they go through and you have your very specific driver for your very specific graphics card, it probably reads it and goes, well, don't actually thrash the crap out of our really expensive £500-600 cards, because your £200 card really shouldn't be there. So you really have to think about that. And the same thing kind of goes with Ryzen as well. I've got the MSI software, the Ryzen Master, and I've obviously got the BIOS from MSI as well. Now, if I use the software MSI, the command software, whatever it's called, what it does is it absolutely kills the processor. It's absolutely not good at all. Oh, that way. It's absolutely not good at all. It literally overvolts, chokes the system, runs away, and you get thermal problems straight away. And I'm like sitting there thinking, well, hang on a minute, this is your software. We're not overclocking. We're just trying to run normally with a benchmark, and you fuck up. So, you know, it's really, really bad. Then I went with Ryzen Master, and that seemed to be a little bit better, except the overclock profiles, and you have to change 3 different settings, which is the correct way now of doing it, not your voltage one that everyone keeps on waffling on about. But you changed the ratings on it, and it kept on flipping out the balance between the 3. But then I was getting 4.7 gigahertz on that clock from doing it properly. And then trying to actually reduce the voltage, because if you reduce the voltage it works better, but people obviously don't understand computer software or hardware or engineering or Ohm's law. Now, Ohm's law is obviously how everything works, because a processor is a set of switches, you know, a couple of billion switches, but that's exactly what they are. So you know, the software problem is probably going to be down to the firmware. I mean, I didn't see this, what was it, 9500, wasn't it, back in the day, the ATI 9500, that you flashed it and it gave you 3 models up or something like that and unlocked extra cores, and it was just literally down to the BIOS. And I think that's what they're doing again now, because no company's going to produce a load of, you know, a load of hardware, then grade that hardware, and then, well, that's exactly what they do. Grade the hardware, then disable some of it just so they can do the mainstream, and then keep some of it active for the other one. I mean, AMD do it with their processors. It's, you know, they test them at a certain voltage, see what they'll get to in performance wise before they, you know, crash out or whatever, and then they grade them, and then they become each different model. And I mean, on my one, if I look at hang on, let's bring you over. If I look, this isn't easy. Alright, so let me pull this up full screen so you can't see everything else. So if you look here, hang on, can you see or not? That is the question. Right, okay, so let me zoom right in. So you can see my processor speed there is fairly normalised, and power consumption normalised, and voltage normalised. When I actually done this and set this up, none of that was actually normalised. It was just literally going all over the place, and it was going beyond spec as well. So it was kind of like really annoying. So as you can see, my CPU is at 27 degrees. Where are we? 35, 36 degrees. So, you know, it's not really cooking, but I'm actually running it at 4.2, so above the specification. Now, in the top end specifications, let me zoom back out because I'm sure you don't want to see that so close. So in the specifications and in the testing mantras of the AMD, there's something like a 5% difference between the cores and all the chiplets, or whatever you want to call them. There's a 5% difference in there, but it does make a big difference to what the voltage is on the max voltage, minimum voltage, performance core, and everything else in there is all considered into their systems when they do it. So basically, what you get is a range of benchmarks there that they grade their chiplets on. Then they're divided off into whatever processor brand, version, whatever they want, thingy box, and that's kind of like what you get. So yeah, so in all, you know, you're going to get problems with what you pick, you know, what you get, and that kind of thing anyway. So you're going to get problems with the BIOS because their software seems to really be the limiting factor in actually getting a stable system or stable overclock. If by default, if I just literally put this computer together, it would be horrendous. It wouldn't work at all. I'd be literally sending it back. It's just that because I'm tech minded, I've done this for what, 25 years. Well, actually it goes all the way back to the 1980s, but we'll pretend I'm younger. You know, it goes all the way back, my knowledge goes all the way back to there, so what you get isn't really what you're getting, if that makes sense to you. You can get something that's a lot better, but it's going to be diffused by software applications to undermine the performance that you may be able to get. So yes, don't forget that that's going to be your big issue, and I found that exactly the same thing with the graphics card as well. So it's not just limited just to the processors, they seem to be doing it right across the board. Now, I know quite a lot of inside information, and so, you know, there's going to be, basically they've got really brilliant stuff and they've downgraded it just to give you some feeders to sell you something, and then they just keep on releasing a little bit and a little bit and a little bit, and the breadcrumbs, and you keep following it up to this, you know, magical thing that they developed years ago, especially with graphics cards. That was, you know, a big thing in the 80s, and that's what I expected or would expect on the technology curve. And for probably the best part of over 10 years or more, there's not been really that much in the way of technological development and innovation. It's very basic, so you might want to just think about that, you know, in the last 3 years is kind of like, you know, if you haven't upgraded in 10 years, the last 3 years is kind of like where you want to be upgrading. And on that 3-year note, the usual turnover is 4 years, so we are expecting in year 2020 some impact of some notoriety this year, and Intel are supposed to be bringing out a new processors and AMD are bringing out new processors than Nvidia too, but them two always battle and you know, blowing smoke out someone's arse generally. So I hope you found this somewhat interesting. You know, you're trying to pick hardware. The only way you can do it is by knowing your software, and then you can pick your hardware. You don't pick the best hardware, you pick the right hardware. I mean, I've had people turn around to me and go, oh, well, why are you using this software? This isn't hardware, this isn't the right one to use, this is much faster. No, yeah, you'll find. And then we bench them and they go, oh yeah, you were right. And it's like, yeah, I just but I have a habit of going, I told you so. I'm a bit of an asshole, really. So yeah, if you like the video, I'm going to be doing I'm actually doing my own network. Your video editing and stuff like that, you probably want to do a workflow and a data backup policy and procedures. I wrote the book on those years ago, the RFC compliance. We actually sat there and we talked about how people should do their backups and blah 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 blah, and loads of other rubbish as well. But you know, it's about having the right setup for your network and what you do. There's nothing. The amount of times I used to get phone calls, hi, my computer's crashed, or I got a virus, I've just lost all my data, my hard drive broke, and then it's oh yeah, so what do you want me to do? Change your hard drive over and then restore it from the backup, which is obviously quick and simple. And because you're paying me extortionate amounts per hour, obviously the quickest route is for me just to come in and put a drive in, clone it over, which will probably take about an hour. Or do I need to take the drive away, check the drive to see if I can recover the data on it, or whether it needs to be spent you know, £4,000 or so on an expert recovery company that has to break down the drive, rebuild it and rebalance everything else, and technically build your hard drive again for you. You know, just back up, really. So back up. What was it? If you think, make an adequate backup system, then do it twice is my motto. So you know, it works. But load availability depends on whether you're single to, you know, one or two small SME, or whether you're quite a larger SME with, you know, multiple users, say 10 users is a good example actually, 10 users or more, and below 10, about your infrastructure. It really does make a difference as to what way you would set things up, especially with sharing and data flow and data management and multi-edits and things like that. So it does become a bit of an issue, and you can't just use normal bog standard software as well. Microsoft sorted that years ago, so usually you have to go and get either a data center or the data center engineers out just to configure it so the actual software works properly with the hardware. There is obviously the Linux route, that's pretty good. For most non-user side it's perfectly fine, but the problem is though is that there isn't that many people who are pretty good with the Linux route. Now there are kind of like niches which work, that's fine. But we're going off on a different subject now, so I'm just going to shut up and let you be. So yeah, so hopefully you've got some idea of, look at your hardware, look at your software, then build your hardware. Picking the right hardware is going to be really difficult. Try and go for the right type of hardware, and that's going to be a minefield for you. But a Ryzen 7 is pretty good as a sort of mid-range workstation type. My video editing went from 10 minutes to 2 minutes, and I'm, you know, 3 or 4 times real time in the edit time, so it does really come in a lot quicker, because I was like 0.3 or something like that.